have completed these components: descriptive statistics, data visualization. So initially today we will complete data aggregation also, and then we will also get a new data, and then we will start the data preprocessing. The first half an hour, I will complete the data aggregation part in these things, and we will repeat all these steps: exploratory data analysis, your data visualization, and the data wrangling on a new data set called Big Mart Sales. Analytics Vidya, there is a data called Big Mart Sales. We will download it, and we will run data pre-processing. All those things will be explained through that data. Okay, so HR Analytics is the notebook we are going to use for the first half an hour, 40 minutes of the session, where we will complete the third component of our exploratory data analysis, which is the first step in data science. The first step in data science is exploratory data analysis. Now, for doing this data aggregation, we have a function called group by. Group by is a function which is very widely used here. We also have a pivot table function. Panda's pivot table function is also there, but it requires more arguments. So we will prefer group by. Pivot table, when you're dealing with large scale data, I will explain to you how to do with pivot table also. Now, let us say, what is the average underscore training underscore score of is underscore promoted 0 and 1. So we have a variable called is underscore promoted, which is our dependent variable. Is underscore promoted is our dependent variable for this particular data. And we also have a variable called average training score, which is a numeric variable. Now, what is the average training score of is promoted 0 and 1? Typically, what you should do, you should split the data frame into two. Is promoted 0, 1 data frame, is promoted 1 as 1 data frame. And then you calculate the averages of the respective data frames, average training score. And then you'll get the final average comparison. Now, this whole process will be done in the back end by the group by function. The same process of splitting the data frames based on a condition and then calculating the respective average. So let us run this on this data. HR train dot average training score dot group by HR train dot is underscore promoted dot mean. So the average training score of people who are not promoted is 62.64. The average training score of the people who got promoted is 71.32. So we have 50,000 people who are not promoted in this data, right? 4,000 people are promoted in this data. So it has split the data frame into 50,000 observations, one data frame, 4,000 observations as one data frame, and then it calculated the averages of the respective columns. This is the process done by the group by function in the backend. Right. So we have, then we got this thing. So the rules are here. The left side of the group by, must be numerical. The left side of the group by must always be numerical. The right side of group by, within brackets must be categorical. And a statistical function like mean, median, standard deviation, skewness, kurtosis, etc. must be specified. You have to specify a statistical function. The left side of the group by is numerical. The right side of the group by within brackets is categorical or non-numerical, and you need to specify a statistical function. So the average training score of people who are not promoted is 0. The average training score of employees who are promoted is 71.32. So what we can now make an inference here, the inference is that people who scored higher in their average training, who have scored higher averages in the training are getting promoted. Employees who are scoring less on their training are not getting promoted. So this is the inference we can get from this question. So the question was, what was the average training score of is promoted 0 and 1? Is promoted 0 means the employee is not promoted. Is promoted 1 means the employee is promoted. We have 50,000 employees who are not promoted. We have 4,600 employees who are promoted in our data. So the group by function will split the data into 50,000 observations, one data, 4,668 into one data, and then calculates the average of the average training score column. And that is what it is giving us, 62 and 71. So the group by function will give you lots and lots of inferences, what you call intelligence about the data we are dealing with. What all data points are telling, how we have to interpret, how do we have analyzed. So basically, generally people who score high in training should get promoted, right? And that logic is being validated in this data. That logic is being validated in this data. Now, let us say whether long-term employees are getting promoted or whether people with shorter tenure are getting promoted. So let us say, what is the average length underscore of underscore service of is underscore promoted 0 and 1? What is the average length of service? There is a numeric variable called length of service. How many months or how many years they have worked for the organization. So again, we have to split the data frame into what we call 0 and 1. 0 as one data frame, 1 as one data frame, and calculate the average of length of service. So HR train dot length of service dot group by HR train dot is promoted dot mean. So 5.87 years is the length of service of people who are not getting promoted. 5.71 is the length of service people who are getting promoted. So people with slightly shorter term, not much of a difference, right? Very marginal difference is there. People who are getting length of service and promotion are not that different as compared to a training score. Compared to a training score, the length of service is not as comparable. Got it? Similarly, we have a variable called what is the average underscore training underscore score of awards 1. Awards 1, what is the variable name? Just a second. Awards underscore 1 question mark. Underscore 1, 0 and 1. So awards underscore 1, 0 means no award was won. Awards underscore 1, 1 means they have won the award. Now let us see whether the people who are getting awards have an higher training score compared to the employees who are not getting awards. Just run this query. Awards 1, 0 means the employees have won the award. Awards 1, 1 means the employees have not won the award, has won the award. 0 means not won. 1 means they have won the award. Hey, in the back, you are new, right? You have installed Anaconda Python? You have downloaded the exe file? Okay. If it is work lab, you have to use the online version. Google Collaboratory. Online version is Google Collaboratory. You are not able to install Anaconda Python, then you have to use Google Collaboratory. Google is accessible, right? Google Collaboratory you can use. Colab, C-O-L-A-B. So HR train dot average training score dot group by. Here we have a special character. So HR train square bracket single quotes awards 1 question mark dot me. So awards 1 have higher score 69. People who didn't win the awards got 63. Like this, we can post questions and we can find the answers. What is happening? This is called data aggregation and data wrangling, where we will get even more understanding of the data we are dealing with. 100% understanding of the data is required before we go to the next process of data pre-processing or hypothesis testing. We can do hypothesis testing also, but first we will do data pre-processing and then we will do hypothesis testing. So this is the what we call a simple terms of group by. You can give 2 variables in the brackets also. You can give 2 variables in the brackets also. Like here, I want to have both the KPIs met. Let us say we have 2 categoricals. Awards 1 is 1 categorical. And then we also have one more variable called HR train dot KPIs meta. This also has a special character. So you can also see double categorical variables also you can give. Square bracket single quote KPIs met 88%. So we have given 2 categorical variables, awards 1 and KPIs met. So KPIs will be there, right? Key parameters for your every employee has to define his parameters or what is work thing. So you can see here, awards 1, KPIs 1, 64. Awards 1 and KPIs 1, 68. Got it? So we can do a lot of such question and answer things, which we will be going through. And this data aggregation is a very critical component in data analysis. Copy paste the variable names. Don't type them. You can go up and copy paste the variable names. People who have done this can go to Analytics Vidya and download a data called Big Mart Sales. Analytics Vidya Hackathon, Big Mart Sales. So who have done this can go to Analytics Vidya. So go to Analytics Vidya. In Analytics Vidya Hackathon, you can use your Google ID to log in. Within Hackathon, you will see something called Big Mart Sales Prediction. Third one, after loan prediction, you will see Big Mart Sales Prediction. Register that Big Mart Sales Prediction and download. In the problem statement, you will find the files, train, test, and sample submission. All three files you have to download. You can open Google Collaborate. Google Collaborate. This is online version of so now just why to go to Big Mart register. Just register for that file. Problem statement. Once you register, go to problem statement. All three, train, test, and sample submission. And save them in the Python folder. Create a folder. You create a folder in your Python folder. Name it as Big Mart Sales. And save these files in that folder. Yeah, we have to save it, create a separate folder for this. Every data set you create a folder so that you don't get confused. In the core Python folder only, create a new folder. You also create a folder and give it on your system, desktop or computer. And then name it as Python folder. Save the data sets in that folder. Or all three files and save them in that folder. Create a folder with Mart Sales in your core Python folder, and then save these three files into that folder. All three files are document, train, test, and sample. So open a new Jupyter notebook. People have done it. Open a new Jupyter notebook. Go to the Jupyter notebook homepage. New Python 3. So this is the third data set we will be working upon. Till now we have worked on Airbnb data. We have worked on HR analytics. Now this is the third data with marks. Open a new Jupyter notebook. Python new Python 3. And then import the libraries. Import pandas as PD, import numpy as NP, import matplotlib, or you can keep the other notebook open. You can always keep the other notebook open and copy paste the commands from that notebook. If you are not comfortable with typing, keep the notebook active. HR analytics notebook also open. You can open multiple notebooks. Close it. So it's on the folder. You can mount your Google Drive. So what people have to do is, say you have your Google Drive, click on the Google Drive, last and mount, connect to your Google Drive. So it's very important process is like but we have a process, this is a particular office, but you might not have a administrative life. Okay. Then that year you have to connect to your server now. So you prefer faster internet. All these are mobile hotspot to have any issue with the internet here. Sometimes here it becomes very slow. You download those 3 files and I'll tell you how to. And set up the working directory also. New Python 3. Import pandas as PD. Import numpy as NP. Import matplotlib. The core libraries which you need to import every time you work on Python project as PLT percentage matplotlib inline. Online days we are working on analytics with the Big Mart sales. Analytics with the hackathon. Big Mart sales. The problem statement, you will find the file. So for setting up the directory, import IO, %CD, Windows laptops, double quotes, Mac, single quotes. Go to the folder where your data is there. My data is in hackathon, Big Mart sales, get info. You guys right click on the folder, properties, security tab, object name. Big Mart train is equal to pd.read_csv. double quotes. Yeah. That's why you copy from the previous one. P by P and only. I plot. Look at the name. Or you copy paste from the other notebook. If you find difficult. You want to Google on the track. Now, what you can do is, my you can create a folder here and save the data files. Okay, one more. Or you can upload it outside the session. Okay. And then every time you have to upload it. Because once you upload the data in Google, it will be there forever. But if you upload it in the temporary session, once the session goes, better. So create a folder here. So don't have to collect one. So automatically save the note to collect. So create a folder. Big marks. Transfer the files. So we go to Google Drive, paste 3 files. Several reported can run at shape and details on parent data. Right? They shape details. The functions which are run are running for the data. So how many rows and number of variables? 8,500 and variables? 20. 12 variables. D types you have both int, float, and object, right?
The object. Yeah.
Int, object, and float. It's first training with the computer. उसको minimize करो, not train now. Open brackets, first open brackets, round brackets open करो, double quotes दो, आपके फाइल के पास जाओ, right click on train, now you are clicking on test, right click on train, properties, copy the first name, copy name, copy, see, dot CS no save that, but paste it, dot CS, now shift plus enter, save it for test. See, that is what the kind some things are there. So what is your whole about? You have your own rules. You can copy paste from here. Same data, you just change the folder name. So what is the folder name you have to give? Did you give anything? Say. Because it's the problem with expert is you have issues with change into Google. Now let's come to the control. Two double process. Big mark, all caps. We got the books and all that. No, see, if you capture any end of this side, special characters. Exactly what is the data? No, I think there's go to Google Drive. Not train, not carry. Look at the name, what you have given. First import the libraries. Import pandas as PD, import compare as NP. Import pandas as PD. Import compare as NP. We can do the spelling. You keep the path somewhere with the text file. Okay, so that whenever you copy paste, add the folder, new folder, and that's that we will avoid errors. Percentage map dot rate space inline. This is the graph and the shift plus or you can click on this triangle. Or keyboard shortcut is shift plus. Okay, shift plus enter. You create a new cell. Shift plus enter. Run the cell. Create a new cell. Okay. Now big mark train. Big mark train. PD dot read underscore CSV open bracket double quotes. Now this is the structure to the train file. You see three dots. Click on three dots. Copy path. Paste the path to the control which is present. Now similar process of test data. Test data. And then you can close the after copying and paste the path, then close the code. So then you can Generally, whenever we import the data, what are the commands we run? Train. Big mark. For autofilling, type the first three letters and press the tab. Dot head. Big mark test dot head. Sorry, tail. Bigma train dot head is for the first 5 rows. Bigma train dot tail for the last rows. Right? And every function should have round brackets, parentheses. Every bracket should have parentheses. Dot head and dot tail. Data frame name dot HEAD head null brackets. Bigma train dot tail. Bigma train dot tail. You will see the last 5 rows of the data. Dot head and dot tail. Okay. Now, how about this? Now, that's why I think it's not like that. I think the title is no, real-time got disconnected. See, the numbers runtime disconnected will get. That means you are unable to connect to the. This is cloud version. That means implement with the cloud. Okay. I think also a system is some driver working the back. So Bigma train dot shape. Dot shape will give you first what? Number of rows and number of columns. Shape will give you first number of rows and then number of columns. Bigma train dot D types, individual variable data types. Individual variable data types. The shape will give you number of rows and number of columns. D types will give you the individual variable data types. And then Bigma train dot columns will give you the name of the columns or name of the variables. Name of the columns or name of the variables is given by the function columns. Yes, every time you import the data, you have to run these functions to understand, have a basic level understanding. A deeper understanding will be generated after EDA. Because you will get data in a dump. Here we are getting in table format. In real time, you will not get it like this. They will give you an Oracle DB dump, or they will say, give you Oracle at DB access with your ID password and say, you download your own data. So that is how industry works. If it is dump means there will be a lot of variables, columns, you have to come through, minimize them, all those things have to be done. Generally, clients give the dump. The dump might be 5 GB, 10 GB. You have to go through the dump, identify, it will have multiple sheets. So initially you will do SQL queries and then bring the whole dumps into different data tables and sheets. And then based on the data, we will start working on the machine learning, or sometimes we have to stop with exploratory data analysis only. Not every data is suitable for machine learning. Okay, so that's how it works. So initially you will work on a lot of SQL. That is why recruiters ask for compulsory SQL advanced level knowledge. SQL advanced level knowledge is must, followed by Python or R. So I will cover MySQL also later. I think you have MS SQL, you have covered, right? Microsoft. MySQL is an open source SQL, which is having a bit advantage compared to MS SQL because it works on large data. And we will also work on PostgreSQL. PostgreSQL is for very large data, terabytes and petabytes of data is there. PostgreSQL or Apache Hive SQL, Hadoop SQL, there are different work. Command, all the functions are same. Select, create, alter, drop, same functions. Only minor syntax changes will be there. Some places we use semicolons, some places we use spaces. So like that, it will differ. But the initial process of data science starts with SQL because you have to go through the dump and then you have to sort through the dump one by one. Not one person, 5-6 people will break the dump and then accordingly you will go through it and then you will generate the data tables. And once you generate the data tables, then you explore for any possibility of machine learning or simple exploratory data analysis will be done. Okay. So this is, we have done the Bigma train dot columns. We have train data and test data. What is the difference between train data and test data? Anybody? We discussed in the last session. Train data is complete data with dependent variable. Test data will not have the dependent variable. What you have to do is you have to build a model on the train data and use the train data model to predict on test data. The dependent variable will not be there in the test data. Train data is complete data with dependent variable. You have to build the model on train data, and using the train data model, you have to predict for test data. Now, before doing this process, we need to do data cleaning or data preprocessing. Now, the fundamental rule in data preprocessing is whatever preprocessing you are doing on train data, same preprocessing must be done on test data. Whatever data preprocessing steps you are running on train data, same preprocessing steps must be run on test data. Otherwise, your models will generate error. So what we do is when we are doing data preprocessing, we tend to combine both the data frames, concat both the data frames, and then do the preprocessing. And once the preprocessing is done, we will split them back to normal train and test data, and then we'll go into hypothesis testing, then we'll do the data wrangling on train data, and then we will build the models. That is the whole process which you do. So data preprocessing is very, very critical step. 90% of your time will be spent on data preprocessing. Machine learning models just take 1 minute or 5 seconds. But bringing the data to the shape where we can build a model is the challenging task. 90% of your time is spent on data preprocessing. Okay, so today I will discuss some of the common data preprocessing tasks we generally do in data science. Okay, so data preprocessing, also called as feature engineering. Some textbooks use the word feature engineering. Features are nothing but variables. Variables are features. The first step here is you have to check for duplicate variables. If your database is not properly defined, you will have duplicate variables coming into your data. Duplicate variables is one of the problems. You have to find those duplicate variables and remove those variables. You can generally duplicate variables might have same name. They have same name or different name. Now, this is done based on manual inspection. So you have to go through, if you suspect some of the variables are duplicate, you separate those variables and check them for duplicacy. Whether the data points are exactly same or not, you will check. If they are same name, you remove all those things. You can drop those variables with same names without any doubt. Sometimes they have different name. Different name means by default, database will add _1 as the additional variable. So let us say you already have gender variable. Now gender duplicate is created, gender _1. Gender and gender _1 are same variables. Because of mistake in defining the DB guy made a mistake, a new variable called gender1 came into picture. Gender _2. Again, somebody has defined. This happens because of the communication gaps between the data administrators. So you will have these problems of duplicate variables. So whenever you go through the dump, you identify the duplicate variables and we will eliminate those duplicate variables. The best way is through manual inspection of the variables. Or some people try to write for loops and all those things. You can, while you once you join the industry based on the large scale data, you can write for loops. When you write a for loops, if a variable has same min, same max, same standard deviation, that means it's a duplicate variable. You can write a, so if the variable has same min, same max, same mean, same median, same Q1, same Q2, what are these? They are functions of describe, right? These are the outputs of you have the same describe function output, right? If your variable have same, if the variables have same min, same max, same mean, median, Q1, Q2, Q3, then you turn them as duplicate variables and eliminate them from your data. So you can write a for loop. You can write a for loop. This requires a little bit of comparison of little bit of programming, guys. A Python programmer will be there for you to assist. So if you can write, it's okay for you, or else you'll have support of a Python programmer, which you tell him your requirement. I want to compare this output of all the variables and sit with him. He will write a function. You check the function and then you can identify the duplicate variables. Right? So duplicate variables is the first part you have to check. How many duplicates are there? Duplicates happen when the database is managed from multiple locations by multiple people, because of the communications. We have seen even today duplicate variables coming into picture. Okay. The second thing which you need to is single value columns, single value variables. That means the whole column has same value, like 0 or 1, or sometimes yes, you know, sometimes the DB guys over 18 years old. Will you have an employee less than 18 years old? Right. So that means over 18 years old means for all the employees it will be Y. Right. So that's what happens when you don't define your DB or your database is not properly defined. You will have these single variables. I have seen in HR data regularly over 18 years old. Yes. What is the point? Because you know employees must be above 18 years old. So sometimes we have this one. So some employees, like, you know, sometimes we also see this thing called what you call employee background verification. For all the employees, verification will be done, or social security number submitted, or in India PAN number submitted. When you're joining, you must have PAN number, right? Otherwise, your what you call onboarding process will not be completed. Every employee in India has PAN card. Yes. Number might be different. Is PAN card yes or no? That column will be yes. You have to find that single value columns and eliminate them. So this is one problem we need to deal with. The third and the most important and challenging is missing values imputation. Missing values. What should we do with the missing values? By default, Python will impute null cells with NaN or NA. By default, Python will impute null cells. Null cells means without any value. Those cells that does not have value will be imputed with NaN or NA. Now these missing values must be treated. Without treating the missing values, you cannot run any algorithm. Now the first option in missing value treatment is drop the missing value rows. Drop the missing value rows. Now when will you do it? If NAs are less than 1% and large data available. You have large data available, we can delete those missing values. Less than 1% and large data is available, we will drop the complete rows. All the complete row will be deleted. Okay. In that row, one cell is missing means the whole row will be deleted. Second, if the variable has greater than 70% missing values, then impute with word missing or not available. So if there are very large number of missing values in a particular column, we will just impute the missing value with the word missing or not available. See, if less than 70% missing values, then manual imputation can be done. Manual imputation can be done. If it is a numeric variable, what will you impute it with? Mean or median. If it is categorical variable, we will impute it with mode or also called as most frequent. Mode or most frequent for numeric variable and categorical variable. This we call it as manual imputation. You will calculate the mean of the column and replace the missing values with the mean value of the column. If mean is distorted, you have to use median. And if it is a categorical variable, mode or most frequent. Now this is manual imputation. Now, one important thing you need to understand in manual imputation is manual imputation does not take into consideration the impact of other variables, impact of other independent variables for imputation. Because we are calculating that single column's mean and then replacing it, right? We are not considering the impact of other independent variables on this variable while imputing. We are just calculating the single column mean or median or mode, and we are imputing it. We are not looking at the impact of other independent variables, which should be the best practice, right? Rather than doing a manual imputation, if we can do an imputation process where it considers the impact of other variables and then does the imputation process, that is considered as a statistically robust process, statistically reliable process. Now that can be achieved by algorithm-based imputations, algorithm-based missing value imputations. Algorithm-based missing value imputation is one of the important things which you need to understand. There are algorithms which are used within the data science field. One of these is multivariate imputation using chained equations, also called as mice algorithm. This is a very popular algorithm, multivariate imputation using chained equations. This will impute simultaneously both numeric and non-numeric variables. This will impute both numeric as well as non-numeric variables. Mice algorithm, very interesting algorithm which imputes both the numeric as well as non-numeric variables simultaneously. It is one of the robust algorithm in imputations. The second popular algorithm is KNN imputation. KNN imputer. K nearest neighbors. This is one of the popular algorithms we will study in detail. K nearest neighbors algorithm is used for missing value imputation. So KNN uses Euclidean distance. KNN uses Euclidean distance and imputes with the closest value. You know Euclidean distance, right? So based on the closest distance, it will impute the value. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Euclidean distance. Euclidean distance is calculated by default is 5. So it will calculate the observation and the nearest 5 observations distance, and whatever is the value of the closest 5 the observation distance, based on that it will impute that value. KNN imputer is also very, very popular. It's a distance based algorithm. We also have another algorithm called probabilistic PCA, which is based on principal component analysis algorithm. We will study this algorithm also in detail. Component analysis algorithm is used for imputation. So new algorithms are also being developed. But these are the popular algorithms which we find in what we call Python. So this is the biggest and the challenging task in data science. And the success and failure of your machine learning models will depend on how well you have done your missing value imputations. If you have not done your missing value imputations properly, your algorithms will tend to fail. This is the biggest challenge, and this is the biggest task within the data science, because whenever we get data, we obviously will have missing values. And that missing values must be treated before we go into any sort of analysis. Okay. Any doubts in missing values? The fourth important process is data transformation. The fourth important process is transformation of independent and dependent variables. Transformation of dependent and independent variables. Data transformation is a very important part of our pre-processing. Now, first let us look at our dependent variable. Dependent variable, if it has positive skewness, if the dependent variable is highly positively skewed, we can do logarithmic transformation or square root transformation. So 95% of the times logarithmic transformation will work. Logarithmic transformation or square root of transformation if you have positive skewness. In the previous data we've seen, right, we have very high positive skewness. If that variable is our dependent variable, we must treat that skewness. Even sometimes in independent variables, if it is highly skewed, we have to skew that variable. We have to transform that variable. If your dependent variable is negatively skewed, if your dependent variable is having negative skewness, what will you do? The opposite of logarithm is what? Exponential. Exponential transformation or power transformation. If your dependent variable is negatively skewed, then you try to correct it by using exponential transformation. That means instead of taking actual values, you will take the exponential value of the data. 2 to the power e to the power of, you will take 2.7 to the power of the value. So if the dependent variables are highly skewed, we must correct them. We must correct them. Now, does it eliminate skewness? No, it will only minimize it. You cannot eliminate skewness. That you keep in mind. We always want to minimize it to an acceptable level. You cannot eliminate it completely. You cannot eliminate kurtosis. You can only limit to an acceptable level. And normal distribution or bell curve is always a hypothetical situation. We will never get it in real life. So dependent variable skewness we must correct. I will show you how to correct it when we go through the data process. All these steps will be implemented on the various data which we are going to work. Okay. Then now let us look at the independent variables. Independent variables, sometimes we must do some sort of transformation needed if they are in different mathematical units or highly skewed. Now, sometimes you will have your independent variables in different mathematical units. Take, for example, house data. The price of house, how will you quote a price of the house? How will you quote the price of the house? In lakhs, right? The price of the house is 80 lakhs, 75 lakhs, 90 lakhs, like that. The size of the house? Square feet, right? Thousands of square feet, 1200 square feet, 1400 square feet. Price is in lakhs, whereas the size is in 1000 square feet. Parking area, 125 square feet. Like that, you have data in hundreds. Number of bathrooms, 2, single number, discrete. So when you have data like this in different mathematical units, you must do something called standard scalar. You have to implement standard scalar must be implemented when your data is in multiple mathematical units. Standard scalar is nothing but Z score. What is the formula for Z score? X minus mean divided by standard deviation. You will calculate the Z score of each of the observation and replace the actual values with Z scores. Now, standard scalar will give you both negative as well as positive values. Scalar will give both negative and positive values, because some values will be below mean, some below values will be above the mean, right? Some values will be below mean, some values will be above mean. The second type of thing we generally use is min-max scalar. Min-max scalar is also there, which is a very popular scalar in image processing. The formula is x minus x min divided by x max minus x min. Now, min-max scalar will scale all observations in the range of 0 to 1 without negative values. Without negative values. We will not get negative values in min-max scalar. Standard scalar, you will get negative values also. Whereas in min-max scalar, you will not get any negative values. And all the values will be between 0 and 1. Min-max scaling is called normalization. Standard scaling is called standardization. Standard scalar is also called as standardization. Min-max scaling, we call it as normalization. So min-max scalar, we will widely use it in image processing. Image processing, we must scale the data. That too min-max scale, because already image data will be very large, right? Pixels data will be very large. To reduce the size of the image pixels value, we run the scalars. Otherwise, you cannot process them on your CPUs. So data transformation is a very, very important part of your data science. For dependent variable, we have certain methods. For independent variables, we have certain methods. These methods need to be employed based on the data you are dealing with. Got it? Now, the fifth process, which is very important is correction of duplicate levels in categorical variables. Correction of duplicate levels in categorical variables. Take, for example, we have a variable called gender. You have data as male, you have M, you have capital M, you have MALE, you have MALE. Python treats each one of them differently. But all of them mean only one thing called male. So you have to find out whether there are any duplicate levels in your categorical variable, and accordingly, we must correct those categorical variables. Sixth process is dummy variable encoding. Dummy variable encoding, or assigning numeric identifiers to the classes or levels in categorical data, all the categorical variables must be converted into numbers. You should not have a single alphabet or single text in your data when you send the data to your algorithm. If you send the data with character text data in algorithm, the algorithm will simply say string found, algorithm cannot be run. There should not be any single alphabets in your data. You have to convert all the dummy, we call the processes dummy variable encoding, where we convert or assign numerical identifiers to text. Take, for example, in this process, we have multiple. In Python, we have two processes. The first one is label encoding. Label encoding will encode in the same column. It will encode in the same column and overwrite the column. So take, for example, we have gender. Male, female, let's put small. Male, female, male, female, male, male. So we have gender like this, text data. Now what label encode will do is, it will assign in alphabetical order. In alphabetical order, which will come first? F will come first. So 0 will be assigned to F. 1 will be assigned to alphabetical order. The label encoding will do it in alphabetical order. This we call it as label encoding. So it will overwrite the existing column with the numbers starting from 0. Starts from 0 in alphabetical order. The second process is get pandas, pd dot get underscore dummies. pd dot get underscore dummies will create new columns based on the number of classes or levels. Okay, so if you take the same gender data example here, if you take the gender data levels and does binary encoding, binary encoding is no is always 0 and yes is always 1. No is always 0, yes is always 1. Now, what it will do is it will create new columns like this: gender underscore M, gender underscore M. It will create a new variable called gender underscore M, and if the value is there, it will give 1. If it is not there, 0, 0, 0, then 1, 1, 1, and 1. It will also create a new column called gender underscore F, and then 0, comma 1, comma 1, comma 1, 0, comma 0, comma 0, comma 0. So two methods of encoding in Python. Label encoding will do it in the same column. Get dummies will create new columns. So be careful when you are using get dummies, because it will create new columns. The number of variables will drastically increase. As long as you have the number of rows, increase of variables is not problem. But if you have less number of rows, increase in variables will become problematic. If it is a large data, you have data in lakhs, then a 50 variables after get them is becoming 150 is not a problem. But if you have very small data, then it becomes a problem. So based on our requirement, we can either use label encoding or get dummies, the two functions which are there we have to do dummy variable encoding before we do any other process. All right. The next process is create new variables from existing variables. Create new variables from existing variables. We will create new variables from existing variables. So calculating net price from gross price after deducting discount, or how much is the bonus given to the employee. Based on the percentage, you'll calculate and give bonus, add a bonus column to the data with the amount of bonus for each employee. Such variables will be created. It is dealing with dates. Dates by default are read as object, and dates must be converted into date time square bracket ns format. So dealing with dates. Dates is also a big problem in data science. By default, dates are read as object. You have to manually convert them into date time ns format. We have a function called pd.to_datetime, which will convert any date in any type of date to date time format. Okay. 9. What is the 9th one? Forgot. Something I forgot. After date times, new variables, existing variables, what I forgot. Extracting information from dates. Extracting information from date like year, month, day of week, whether it is Monday, Tuesday, Wednesday, like that. Then quarter, which quarter is month start with the first day of the month, like that. You can get lot of information from dates. Extracting information from dates is one other thing. Then the 10th one is reducing the variables, or we call it as dimensionality reduction. Dimensionality reduction, or reducing the number of variables. Dimension reduction or reducing the number of variables. So broadly, these are the 10 steps which we do in data, but there are many. Each data presents its own challenge. So not that these are fixed. Each data has its own challenges. So nothing is fixed here. Based on our data, type of data we are dealing with, we have to come up with different strategies and solutions. Broadly speaking, these are the 10 common data pre-processing techniques we need to do. Suppose you're dealing with text data, natural language processing. That's a different pre-processing. Suppose you're dealing with image processing, that's a different pre-processing. So what I am talking today in terms of pre-processing is for a multivariate data analysis. Multivariate means data in terms of numbers and categories, categorical data. When we talk about natural language processing, we will do a different type of processing. When we talk about image processing and deep learning, we will have different set of pre-processing. This pre-processing, which I have told you, is all about multivariate data. Multivariate data means data that has both numeric variables and non-numeric categorical variables. We call it as multivariate data. All right. Now, big bot train dot is null dot sum dot sort underscore values ascending is equal to false. This will help us to identify missing values. To identify any or missing values, we have to use this function is null. Is null is a function that is used to identify the missing value. Then it will sum up all the missing values. Then we are sorting them in descending order. So we have missing values in two variables, outlet size and item weight. Now also run the missing value thing on test data. Also check the test data for missing values. Okay. To check the missing values in the test data, same command. Only thing is you have to change the data frame name, which is bigmart test dot is null is the function to find the missing values, dot sum to total all the missing values, dot sort underscore values to sort them in descending order. Ascending is equal to false. So we have missing values in similar columns in both the data frames. We have missing values in similar columns in both the data frames. So what I told you, when you have such sort of situation, it's better to concat them or merge them for cleaning up process. For cleaning up process, we will try to merge the data frames or concat them into one for cleaning up process. Now, for that to work, we need to have similar print bigmart train dot shape print bigmart test dot shape. So in our train data, we have 8,523 rows with 12 variables. In test data, we have 5,681 with 11 variables. One variable which is not there is the dependent variable, right? The dependent variable will not be there, which we need to predict. Now, for concatenating data frames, the number of variables must be equal. So we have an option. Either we delete the dependent variable from the train data and then concat, or temporarily add the dependent variable with a null with a sample value to the test data and then concat. Best practice is we will add the independent variable to the test data so that you can use it as a conditional statement to split the data back to train and test. So as long as the columns are not equal, you cannot concatenate them. One option is deleting the train data, one variable deleting, which is the dependent variable, which is again a problematic situation. You have to store it in some place and then delete it. Or adding the dependent variable with a simple value like test to the dependent to the data set and then concat them. Later we can use is equal to test as test data, not equal to test as train data, and then we can split it back. So we will add the dependent variable, add dependent variable to test data for concatenation of data frames. So what is the data frame? What is the dependent variable here? Identify the dependent variable. What is the dependent variable, participants? Yes, item, outlet, sales. See, in the train you see in the last, right? Item, outlet, sales. Copy this, Control C. Now, what is the data frame name? Big Mart test. We are adding it to the test data. Square bracket, single quote, item outlet test is equal to test. So it will add a column called item outlet sales to the dependent variable to the test data and fill all the cells with one value called test. You can't leave the cells empty, right? That cells will be filled with the word test. So that we can use that as a conditional statement to separate the data back. Is equal to test, not equal to test. Right. Now we have added an additional column to our Big Mart test data and filled that column with the variable where the value called test. Now we have equal number of columns in our data. Now we will do concatenation. What type of concatenations we will do is row-wise concatenation. That means paste all rows of train data first and below paste all rows of test data. So first it will paste all the rows of train data. Below it, it will paste all the rows of test data. Right? So that there is no mixing of data here. Concatenation will first paste all the rows of train. Below it, it will paste all the rows of test. So there will be no changing. Only it will do the concatenation. So that is the advantage of concatenation. Merge and join might what you call interchange the data here, but in concatenation there is no interchange of data. All the train rows first, below test rows. So combine df. I am giving a new name called combine df is equal to pd dot concat open bracket square bracket. What we are pasting first? Big Mart train, comma Big Mart test, comma axis is equal to 0. Axis is equal to 0 is row concatenation. Axis is equal to 1 is column concatenation. Axis is equal to 0 is row concatenation. And axis is equal to 1 is column concatenation. Column means first paste one and then next to it paste the other. So here you have to give axis is equal to 0 because we are pasting rows, right? First train rows, then test rows. We are doing the country. So combine df dot shape. See 14,204 variables of sorry 204 observations of 12 variables. 14,204 observations of 12 variables. So 8523 plus 5681. All right. Got it all of you till this point? Now, what is the first missing value? Outlet size. Outlet size definitely would be categorical variable, right? Size of the outlet will always be categorical in nature. So combine df dot outlet size dot value counts. What is the drop NA is equal to false. What happened? Error, huh? Please don't hesitate. Call me if you have errors. What is it? No, it will be great. Auto-saving, huh? The biggest advantage is auto-saving. Yes, this is the home page, right? Then we see here. Now what I go. It is auto saving, so it will be there. You don't need to save it in you gave this name wrong, right? I is captured. So first you have to re-import the data into it. Because that permanent added a problem because this is what I captured now. I is captured. So first correct the I here and then run on the cells from P dot A kind of process. Yes, run or run on. First change the correct. Make it capital. And you got run all cells. Run all cells. See, don't worry. Python, Jupyter Notebook, auto save. It will save automatically every 1 minute. It will be there. That is another advantage why we use Jupyter Notebook. Saves everything. Please don't hesitate. You have any doubt, mistakes, you call me. Initially, first 10 day sessions will have. After that, we will fall into place. We will identify all mistakes. And I told you now, notes I will share. Don't waste time on notes. Focus on the functions. Everything will be shared with you. The video, everything will be shared with you. So how many missing values are there? 4016. Right. If we add this 4016 with medium, it becomes 8000 something, right? Then it becomes a very big class. If we add it to this also becomes 8000, which will become a big class. And high is always less. If you add this, the data will be distorted. So when you can't decide whether what should be the replacement, should I replace with small, should I replace with medium, and if I replace with high, you will distort the data. So what is the safest strategy? Replace with the word missing. You understood that replace with the word missing? When you are not able to decide what should you do with the missing value, because if you add those 4000 to medium, medium will become very large class. You are creating a bias in the data. That is a wrong pattern, right? Similarly, if you add it to small, it becomes 8000. Again, it is a wrong pattern. If you add it to high, it becomes large. Again, it's a wrong pattern. To avoid that mistake, if you can't decide, then what we should do? Replace it with the word missing. You will create a new category called missing. That's a safe side strategy. If algorithm is used on this data, algorithm will study other variables and then it will do imputation. That is a robust imputation, then it will add this 4016 sum to this, sum to this, and sum to this. Algorithm can do that, but manually we cannot do it. Algorithm will study the relationships between the variables, and then it will allocate based on its understanding, some of them to here, some of them to here, some of them to here. But manually we can't do it. I'll show the imputation process also. Can and imputed also will do it. And then how it imputes, we can see. As of now, we will impute with the word missing. We will impute with the word missing. So combined DF dot outlet size is equal to combined DF dot outlet size. There is a function called fill NA. Fill NA double quotes missing. Fill NA will only fill the cells where it sees NA. It will not touch any other cell. Now, if I run this and if I run my previous command, a new category is added called missing. A new category is added called missing. Manual imputation. What I have done is manual imputation. We will also do algorithm imputation on this data when we are working with R. When we are working with R or sometime later in Python, we will do an algorithm imputation on this data. Then we'll compare how what is data and all. So I filled the missing values with the word missing. So missing is added to the categorization. All right. So we'll continue our discussion post break. We'll take a 15 minutes break and then we'll meet at 11:15. Yeah, not live. Live, I'll do it with upgrade and all, but that's not there. But this, you can, all the videos are available here. If you have any doubts, you can, if machine learning, Python, R, everything is there. Huh? Projects are there. Projects, what we are doing are all live projects. Na? Most of the videos have live projects on them. So this is like COVID X-ray classification, image processing. So we have done it on COVID X-rays, real-time data we have taken, and then the image classification. Similar deployment video I have not uploaded. Deployment video did I upload? I think I didn't upload deployment video. Deployment PyCharm, it's there. Deployment is there. So Google Drive. Deployment using PyCharm as an application. You have to appreciate it. And it will be PySpark. Also deployment is there. See, deployment, I think I've got only PJ17 and PJ20 PyCharm model deployment. Oh, it's there, and the latest is also there, but it's in my Windows laptop. We use PyCharm to deploy.
So, pandas number.
So, day before yesterday we have this, right? So, finally, you will get an application page where you give the data, you give the data like this, it will predict what is the value. So, PJ20 guys yesterday created one more for what you call
mismatch. Yes.
Some other
Got the exact prediction.
loan prediction model they created. PJ
21.35.
that I will upload. This YouTube channel has all the videos, almost all. I'll keep on uploading. So I have to do short video uploads because people are asking for interviews and all. So yeah, but we see you are not expected to do it in industry. Data engineering guys will do it for you because you are not familiar with AWS, right? Since you are not familiar with AWS or GCP or Azure, data engineering guys will do it. Hello. So if you want to do deployment also, you have to do this course if you are interested. Azure DP100. Azure is easy compared to the other AWS and GCP. Designing and implementing a data science solution on Azure, Microsoft Azure. This exam is fees. The course is free to learn. You can learn from the videos. There are a lot of materials here. Exam fee is 4,800 rupees. Okay. Yeah, this is official certification. Once you clear the exam, you will be given. So it covers this one. 20 to 25% machine learning, 20 to 25% experiment, 35 to 40 deployment. This one. So online material is free. You have all the materials here, videos, some bits and all. Instructor led is paid. So this will cost you some 30,000 or something like that. But you can learn. Once you complete the Python course here, you can learn on your own and you can appear for this exam. So DP100 is very interesting. So if you have Azure DP100 certification, your CTC will go up by 1.5 lakh. If you look at PJ17 girls who are placed in Capgemini, some of them are now asked to learn Azure. So again, it will be why to do waste time in learning again. So if you have pre-learned it, you can jump into client and all everything. You will get your package and everything ready. So that's how it works. So if you, I would suggest practice, and also if you are interested, go to this Azure DP100. Lot of videos are there on YouTube, lot of materials are there, exam materials are there. So plan it sometime next June onwards. You can start studying from June. By the time we'll complete half of the Python portion, then it should be easy for you. Because if you have cloud certification, 1,50,000 plus to 2 lakhs they're offering. for the person who doesn't have it. And also do an SQL course, EDX. So what happens is, I'm not sure how much you're comfortable with SQL. So, you know, EDX, right? Microsoft's online training. Here, there's a course by IBM SQL. The thing is, they will teach you the basic functions of SQL. That is okay. That is okay. But SQL, Introduction to SQL, SQL for Data Science by IBM, these are, this is like, you know, they will teach you SQL, which you can use with any, what you call compiler, be it Python, Hive, MySQL, MS SQL, anything. It is free of cost. Okay, free of cost thing, free cost, but only 1 month access. So if you register, you have to complete the course in 1 month, right? If you want certification, you have to pay 7,690. Otherwise, it is free. You can go through this course. So what they will talk about is they'll give you select, insert, update, delete, a basic understanding of the concepts. Okay, and this basic understanding concept is irrespective of the SQL tool. You can use the same concepts for MySQL, MS SQL, Hive SQL, PostgreSQL. So you need to understand, because the syntax is same for all the things. So this is one interesting course. You can do it. And then the other one is SQL for Data Science by IBM. Both are free courses. Okay, so very, very interesting courses you can do. So SQL concept for data engineers and data science. For data science, you can do. So here starts from 1. This is also free course. What you will learn is how to sort, group, analyze, all those things. Functions are there, na? Group by and all, order by, min, max, average, all those things will be there. So anyway, I will also cover them in MySQL. I will teach you MySQL after completion of Python. Couple of 3 sessions, 4 sessions of MySQL with large scale tables and all. We'll try to do those things, and then we'll do the queries. And then after R also, before you go for placement, you will do MySQL again, SQL again. Hello. Hello. So start working. I would say before Azure also work on these 2 SQLs. This is 111 limited thing. So once you enroll, it has a 1 month standard time. Very simple things. You can go. Your skill knowledge will drastically improve. And also practice SQL once a week. On some the DBs are available, right? You can see a lot of DBs available on internet. So, or you have sample. If you want, I'll give you the DBs. You can practice SQL, because SQL is very important. 30% of the interview questions come from SQL. So primary key, foreign keys, sequence of execution. Okay, what you call conditional statements, where, then order by, sort by, group by, all those things they will ask you. Which one? Yeah. Yes, yes. See, whatever you are going to add to the project, the fundamental is you should be able to explain to the recruiter. If you are confident enough that I am going to explain this to any recruiter, you can add it in a GitHub profile and put it on your resume. Anything which you feel complex, which you think you cannot explain, avoid it. Don't put it in it. Put it in your resume. Don't talk about it in the interviews. If a question is asked, you simply say, I know the concept, but I'm not 100% confident. Whatever basic knowledge you have, you can do it. But don't put anything which you are not comfortable with in a GitHub profile or in resume. Okay, so that is how you decide which project to put, what to do. Because some people are comfortable with regression projects, some people are comfortable with classifications, some people are comfortable with clustering. So it depends on person to person. But whatever you are putting there, you should be able to explain it to the recruiter in simplistic terms without any confusions. They'll confuse you. It happened with 16 guys. They confused them. They got confused. I told them very seriously. See, boss, you have to prepare and go to, simply putting is not enough. You have to go through it, understand it, practice it and go. And they come to us and say, sir, they confused us. That is the job of recruiter, right? They'll confuse you.
So we have to also mention score.
Yes, you can. You can create a table, model-wise scores. That's what, if you're participating in Kaggle competition. So what was the score when you submitted the model as multiple linear regression? Score when you submitted it as decision tree, score as random forest, score. Then create a table and put it in the thing. That this is the scores I got, which is the best model. That you can do comparative. And don't do anything on textbook data sets. Iris, diabetes, Titanic, O2, all these data sets. Put up. Hackathon datasets, live datasets, Airbnb is a very good dataset. Big Mart Sales is a pre-processing data, Kaggle is a dataset. New York City trips data is there. Because of COVID, they stopped it. Otherwise, New York City yellow taxi is there, no? Trips data is also, it's a very large data. So use all the real-time datasets as much as possible. That way, I know a lot of people in Insofi, they do only on textbook datasets or some data sets where the codes is available. You should differentiate from them and you should have higher salaries, means you should do it in a unique thing. And also get as many badges as possible in EDX. For the course completion, you'll get a badge. Get as many as. So if you have gone through the IBM SQL and all, you should be able to, your SQL skills will be fine-tuned very well. So go through them. It helped the PG18 guys a lot. It will automatically attach. You have an option called, put it on your LinkedIn, it will automatically attach it to your LinkedIn. And licenses, what you call the badges and certifications in your resume, you give the course name and course number. That should be enough. See, you have to create differentiation. Otherwise, you will not get the pay. I don't want to go at 2.8 or 3.2. You should target somewhere around 5. For that, you need to be having that additional skills. So use your time. EDX is better source. Target SQL first, so that you don't forget it. Okay. By the time once you finish Python, we'll do MySQL. So MySQL will be taught to you in detail, where we'll do all sorts of joins with multiple tables and all those things. They are very short courses. It will not take much time. See, because the market is flooded by people, you have to create differentiation. Then only you'll get the higher pace. Every IIT, every IIM is offering data science programs, right? Every university is offering. Even here, JNT is offering, Central University is offering, everybody is offering. People are there in data science. IIT Hyderabad, IIT Hyderabad, everybody is offering data science. But the thing is, companies want people with right skills. They laid off a lot of people. Why do you saw that better.com laid off people? Most of the people are data people because they're not able to do anything. Most of the layoffs are happening in the data science only. They recruited from Insofi and all 3-month programs, 6-month programs, Coursera 6-month program. They recruited them. Once they are given data, they were not able to perform. Then the companies have realized it's not like that. We want a person who had gone through a 1-year program or a long-term program, right from basic statistics to advanced things. They will not ask you a single Python code or R code in interviews. Nothing, no Python code R code. They will ask you about statistics. They will ask you about SQL. They will ask you about machine. They will always ask you which machine learning model you are comfortable and explain it to me, including assumptions and interpretation. You have to explain it to me. If I explained it to the properly without any confusion, with confidence, you are done. The selection will be done. If you can't, then it's end of story. Because we have seen people, we have been telling them theory is more important than R codes and Python codes. Yes, Python codes available everywhere, right? There are millions of websites and YouTube videos, GitHubs, where you can cut, copy, paste the codes. But when to use what? How to answer a question from the client? That is the challenge, right? And the question asked here, why did we use missing? Why didn't you impute with medium or high or small? You can tell them, I'm not sure where to impute it because it is creating distortion. So I imputed with missing, word missing. And if the client still insists, no new category imputed with medium, high and small, you go for algorithm. So tell them, okay, I'll use an algorithm like mice and I'll run the algorithm. Whatever algorithm imputes, I'll give it to you. Because algorithm will not create a new category. Algorithm will understand the variables and appropriate the values into the categories. So if client insists, we'll go to the algorithm. That process you should do once you know the process. But if you don't have any understanding, you didn't work on any real-time missing value data, you don't know anything, right? That's where what happening. That is what is happening in industry as of today also. All right, all of you have understood the feeling. Why use missing as a word? Because we are not sure to which category to add or to which class we should add it. Now let us go to the next one. It's recording only. I didn't stop. Combine df dot item weight dot describe. So item weight is the next variable that has missing values. How will I know if there is a missing values? From this output. From this output, how will I know if there are missing values? What is the actual count? 12,204, right? What was the actual count of combined DF? 14,204, right? 14,204 is the actual count. What is the count showing here? That means the rest of them are all missing values. See here, 11,765. But what is the actual count? 14,000. So we have missing values in your data. Now this variable is in what variable? Categorical or numerical? Numerical. What should we do? Mean imputation or median imputation? Mean is 12.79. Median is how much? The 50% is the median, 12.60. So we can impute any one of them because both of them are closer. Okay, shall we do mean imputation then? Because 12.79 is the mean. Second quartile, 50% is nothing but second quartile. Second quartile is nothing but median. Again 12.60, not much of a difference. You can either use mean or median because mean is not distorted. So I'm filling the missing value with mean. So combine df dot item weight is equal to combine df dot item weight dot fill na combine df dot item weight dot mean. dot mean. You can type in one line because for people to view, I am typing it in two lines, but you can type it in one line. Now I will run the describe command one more time. Now you can see 14,204 observations are back. What we have done basically is mean imputation. Sometimes the data gets corrupted. Correct the error and go to run off and run off. It will automatically. Okay. So we have imputed the missing values. Now let us see what other problems we have. Combine df dot. Huh? Oh, no, wait, I'll check. Again, you got that error?
No, like the numbers.
Yeah, you have raised it, right?
Yeah, but again, this variable is line by line. It says what to say.
Run it again. Now you have to run it again. If I have to run the previous command again. Yeah. Not that is not the plan. The item of the sales, I can't say. It's actually test, correct? Make it both are as training. Change it to test. This has to change to test. We import the data into. Oh. Python programming we will be using at a later stage, not now. Initially, we will not use any of those. Yeah, item programming will be taught about these sessions where we talk about class object-oriented programming. Because this course is only for data science, not for programming. So programming course, that is a different. In this course, as part of this, we will talk about hooks. When we talk about hooks, we talk about iterators, constructors, destructors, and as well as polymorphism, encapsulation, and all. That is only 2 or 3 sessions that have not gone. So, because as per the curriculum given, this is more of data scientist position. What we are talking is Python data program. That is a different.
I'm asking if that would be used, that is useful for this, or we could survive.
We might use them in some real-time case studies, some rules and iterators. Because nowadays Python requirement for programming is very minimal. Because they have developed all predefined functions. So requirement for programming is minimal, but we might use it in text processing. Text and images we might use it. But there will be a session on hooks. Object-oriented programming will be taught to you. 2 sessions or 3 sessions will be there. That will be taught to you in the last 10 sessions or something like that. Okay, so item identifier, we have IDs, we will delete it. Once we check it and then we will delete it. Now let us check item identifier. Combine dir dot item identifier dot head. Look at the item correctly. First, all you have to do is change the test tab. No. Only thing you have to do, yes, you have to do this. You have to put the data right. Now, the second correction you have to do is this item obligations all capitals. That's why I'm telling you, don't make any mistakes and all. You copy from here. You have see, I'm telling you, you are making mistakes in the variable names. Dot and press the tab. See, outlets size, O is capital, S is capital. They should exactly match, otherwise it will not work. Now, item identifier. Can we extract any information from this? Generally, we drop identifiers. Okay, but before dropping, you always check whether it is there, anything can be extracted. If you closely observe, the first 2 letters might represent a product category or an item category. FD might be food, DR might be drinks, NC might be non-consumables. In problem statement, if you have read the problem statement, you have said that it would have definitely said there will be different varieties of items which are being sold. Food items, drinks, then NC. So before we delete item identifier, I can create a new variable called item code. That item code will be the first 2 letters of the item identifier. And the first 2 letters of the item identifier are telling me that they might represent a product code or an item code. FD represents food, DR represents drinks, NC represents non-consumables. There might be other such codes. So I can extract these first two letters from identifier and create a new variable. And then we can delete it. So before deleting any variable, you first see whether you can extract any information from it or not. In this case, I think I can extract something called item code. Item underscore code. A new variable item code can be extracted, combined here, dot item identifier dot apply lambda x colon x square bracket 0 colon 2. Lambda is an anonymous function, which is like DEF function only. What we are telling is split the first two letters of the identifier. So let me see what I got. Combine DF dot item underscore code dot value underscore counts. There are three categories in item code. Food, FD, NC is non-consumables. Non-consumables means soaps, detergents, toothbrush, all those things will come under non-consumables. Drinks, fruit juice, soft drinks, carbonated drinks, they all come under your things. So I have extracted item codes from item identifier. Now I will delete the item identifier column. I will retain the item code column, which will give us more value addition in terms of our analysis. As it is, identifier will not give us anything, but item code will play a critical role in our analysis of data. So any identifier before you delete, particularly alphanumeric identifiers, you check for any sort of extraction can be done from that thing. String extraction. String extraction means in alphanumeric, we have codes, right? Generally, alphanumeric in business means some code will be there. That alphabet might represent some sort of code. Here, the alphabets are representing the categories called food, non-consumables, and drinks. So I have separated them into a new variable called, I have created a new variable called item code. Now we have 13 variables, not 12. One additional variable has been added. But in the end, we will remove identifier and we will keep this code. Got it? So you have to be creative and you have to understand the data, and then you have to start working on this data. So all these things can be generated using your exploratory data analysis, understanding those variables. All right? Any doubts? So what is the next column? Item weight. We have already worked on item weight. So there is nothing to be done in item weight. After item weight, what is the column? Item fat content. Combined here dot item fat content dot value underscore counts. Oh, we have a problem here. What is the problem? Yes, duplication of levels. Right? Low fat, LF, and low fat are all same. Regular and reg is same. Input errors. This is called input errors, where we got the duplication of levels. So we have to correct them. First, correct low fat. Combine DR dot item fat content is equal to combine DR dot item fat content dot replace square bracket single quote LF comma single quote low fat. So first you in replace function, first what to be replaced, and then you will give what is the replacement. L capital, F capital, low fat. Dot replace. First, give the pattern to be replaced. Second, give the replacement. What should be the replacement for that pattern? So here I am replacing capital L and capital F and small low and small fat with capital L low and capital F low fat. Similarly, combine DF dot item fat content is equal to combine DF dot item fat content dot replace. See, earlier we used to write a for loop. Earlier, 2 versions back of Python, we used to write a for loop. Complicated for loop iterator we used to write, and then we used to replace it. Now they have incorporated a replace function. So writing a for loop is no longer required. That is what is happening in Python. Every process, everything which you need are being incorporated into functions. When I first worked on this data, I had to write a for loop. And then we used to do it. Now replace function is added. Without any writing any for loop, we can just use the replace function and we can replace the patterns, reg and regular. Now I'll go back and check the fat contents. Now you can check. They have been correct. So once you run it wrongly, it corrupts the data. So you have to re-import it again. Once the data corrupted, only solution is re-import it back. But before re-importing, correct the error. Once you correct the error, then run all the cells. It will do the re-import and does the corrections. Without doing correction again, it will do the same error. So first correct the error and then run all the cells. It will automatically correct. All right, all of you have done with this? Yeah, error. Corrected? Go back and run the previous, check it whether it's done or not. So combine DF dot item visibility dot describe. Mean is 0.06, median is 0.05, very close. Min is 0, max is 0.32. There is nothing to be done here, right? Okay. What is the next variable? Item MRP. Combine DF dot item MRP dot describe. So 141 mean, 142 median. Again, not much of a difference. All variables are there, all observations are there, nothing to be done. Here. All right. Item visibility, nothing to be done. All there are no missing values. All the values are closer to one another. MRP also nothing to be done, right? Next, what is the variable? Combine DF dot outlet identifier. Outlet identifier dot value underscore counts. So we have these outlets. Outlet 10, 13, 27. They have randomly picked outlets and given us the data. Just go up and say run all. Run time and run all. You see, that is the problem with Google thing. If you don't use it for 2 minutes, now it disconnects automatically. And the internet speed also. Just check the speed test. And you have other links also here. You can come and take a snap. You just take another Wi-Fi where you have. Come here and take a snap. So find the fastest connection and use it. That way we will not have this runtime error. I think this TP link also 5G sometimes works fast. You can see there. Just do the speed test on different things. Whichever is working fast, you put it as your Wi-Fi. Now, the next variable is outlet establishment year. We have the data outlet establishment year. Now, establishment year of establishment, generally we don't, from date, I told you now, we can extract information from dates. Now we can use this establishment year and calculate the age of the outlet. You can take and see age of the outlet as of December 2021. What is the age of the outlet as of the year 2021? Establishment 2021 minus establishment year, you will get the age of the outlet in years. So let us calculate age of the outlet. Calculate the age, outlet underscore age, a new variable called outlet age from outlet underscore establishment underscore year as of 2021. What is the age of the outlet as of year 2021? Combine DF square bracket single quote outlet underscore age is equal to 2021 minus combined DF dot outlet establishment year. So we have added, now I'll delete the establishment year and I'll retain the outlet age. Dot describe. So the minimum age of the outlet is 12 years. The maximum age of the outlet is 36 years. The minimum age of the outlet is 12 years, maximum is 36 years. So I will now delete the establishment year and I will retain the age of the outlet in our analysis. The age is in the years. Age is in the form of years. Minimum establishment year is 12 years old. Then maximum is 36 years. The outlet age is 36 years to 12 years. As of the year 2021. Yeah, it is added a new column in the end. No. So if you look at the combined DF dot head, see your establishment here as it is. See the item code and the outlet types added in here. So your identifier is also there. Your establishment here is there. And then the new variables at the end, code and the outlet age. Item code and outlet age, which I have created at the end. So we have to drop them later. Manually, we have to drop them. Check other variables also. Whoever done this, check the other variables, anything missing or anything is there. We have only some variables. Outlets, size we have already done. Outlet location type, outlet type. Check if you can do anything on outlet location and outlet location type. Because outlet size we have already treated, right? Got it? Combine df dot outlet location type dot value underscore counts. Tier 1, tier 2, tier 3, nothing there, right? Then combine df dot outlet type dot value underscore counts. Supermarket type 1, type 2, type 3, grocery store, nothing to be done. Right? We have done our what you call missing values and some basics. Right? All of you are done till this point, participants? Run D types and tell me what type of data we have. D types, what type of data types we have. Combine df dot D types. Int object, float and int. Now, what is the next process we have to do? We have to do label encoding or dummy variable encoding on object data. The object data needs to be label encoded or dummy variable encoded. So for that purpose, we need to sort the data into numeric data and object data. You should not run label encode on numeric data because it will convert the numbers into ranks. It will completely override the data into ranks. The highest value will be given rank 1 and it will go ahead. So never run label encoder on numerical data. Label encoder or pd.getDummies must be run only on object data or, or categorical data within the numerical data. Sometimes you will see categorical data within the numerical data. Previous session, remember? Awards 1, 0 and 1. It is shown as integer, but can we treat them as integers? We cannot. He is underscore promoted 0 and 1. The data type is integer, but can we treat them as integers? We cannot. We have to treat them as categories. So those value variables which are in numeric data that has to be treated as categorical data must be separated and label encoded. So we will now run the label encoding process on object data. Okay. So for that purpose, we need to understand what type of data types we are dealing with. Combine df dot D types. We have the individual variable data types. We have object, we have item, weight, we have fat content, visibility. So we have float and object and int 64. Right? Different types of data is there. Now, it is better to drop the columns which you don't need. We have already decided we have to drop 2 columns, item identifier and outlet establishment here, because we have extracted some new variables from them. So we will drop them. So let us first drop those variables. combined df is equal to combined df dot drop open bracket square brackets, copy the name of the variables, item identifier. Please do not type, copy the variable names from the previous output, comma, single quotes, outlet establishment year. Control C, Control V. We will drop the two variables, comma, axis is equal to 1. We are dropping the two variables, item identifier and the establishment year, because we have extracted two more variables, item code and outlet age from the data. So we are deleting those variables. Now, if I run my previous command again, I don't see those variables, right? If you run the d types again, previous command, you see those two variables are not there. All right. Now we will split the data into numeric data and object data. We have to split the data. Split data into numeric and object data, because object data only must be label encoded. You should not touch the numeric data. Num calls is equal to combine df dot select underscore d types include is equal to np dot number. Now np dot number will take both float 64 as well as int 64. np dot number will consider both int 64 and float 64 as numbers. Object calls is equal to combine df dot select underscore d types include is equal to square bracket single quote object. Print num calls dot shape print object calls dot shape. So 8 and 4, 12 columns, right? So we are separating the numeric columns and we are separating the object columns. Why we have to do it? Because we have to label encode the object columns. Label encoding means assigning numerical identifier to the classes or levels in the categorical data. Got it? Now we have a problem. Just go up and check object calls. You should find one variable which should be numerical coming in object. Find out the numerical column which is coming in object, which should have come in numeric. However, yes, you're absolutely right. Item outlet sales is a numerical data, right? But we have added the test where number, right? So it is combined data, mixed variable. So it is taking it as object data. It is mixed variable. Half of the data is in numbers, half of the data is not half of. 8,000 cells are numbers, 5,000 cells are test words. So it is taking it as object. But should we encode that data? We should not. So what we have to do is we should move item underscore outlet underscore sales from object to numeric. Since it contains text values. We have created that value called test, right? It is showing as object. It is showing as object. So what we have to do, we have to move it to the numeric columns and delete it from object columns. So what we will do, num calls is a square bracket item underscore outlet underscore sales is equal to object calls dot item outlet sales. So this is numerical data because we have added the test name to it, so it becomes a object data. Now we will drop it. Object calls is equal to object calls dot drop single quote item underscore outlet underscore sales comma axis is equal to 1. Axis is equal to 1 is column dropping. So we are see, item outlet sales is actually a numeric data. For combining that data, for combining the data frames, we have added some cells to that data, to that variable with the word test. So it became a mixed variable. Some data is numeric, some data is object. So it is taking the final data as object. So what we are doing is we are moving it to numeric calls and we are deleting it from object calls. Because anyway, we will separate the data and then we will delete that test and all, and then we'll get back our numerical data. But if you try to put it in object calls and run a label encoder, the whole data will be overwritten by numbers, which will not make any sense. So be careful with these processes of doing this step by step. So you have to be very careful when you're dealing with your variables. Sometimes you have to go through each variable, see where it is, and accordingly you have to move it into the relevant thing. So here item outlet sales should be in numeric calls because it is numeric data. Why it is coming in object data? Because we have added part of the cells with the word test. Right? You remember? Before combining, we added that column to test and then we merged it. So that is the reason why it is coming as object. All of you are done till this point, added the variables and deleted it. Now we are in a position to run label encoder. From sklearn dot preprocessing import label encoder. LE is equal to label encoder null brackets. LE is equal to label encoder. Object calls encode. Object calls encode is equal to object calls dot apply LE dot fit underscore transform. Object calls encode is equal to LE dot fit underscore transform. Fit underscore transform will convert the data from text to numbers. So what actually we have done is object calls dot head to, this is actually our data. we have converted into object calls encode dot head. See? Basically, what we have converted is we have converted the data from text to numbers. So it has overwritten the same column. It has overwritten the same column, right? New columns are not created here. No new columns are created here. See here. So we have once split the data object calls. We have run the label encoder. We defined the label encoder with a short name. And then object calls encode is equal to object calls dot apply le dot fit underscore transform. Fit underscore transform will transform the data from text to numbers. This is our original data. Now see how it converted. It converted into numbers. So low fat is given 0, regular fat is given 1. Similarly, here medium is given 1, tier 1 is given 0, tier 3 is given 2. So it assigned numerical identifiers to each of this data. This is our encode data. Yeah. So this is your encoded data. Understood the difference? It overrided the existing column with numbers. Now the algorithms will not treat them as numbers. The algorithms will treat it as categories. For us, it is showing as numbers, but in the back end, Python will treat them as categories. So when you run the algorithm, they will be treated as categorical levels, not as numerical levels. Got it, all of you? Encode is done. Now, I told you now there is one. Yeah. Yeah, I'll come. Who got the error? No, that is not a problem. That is a warning. Object calls and code. That means the outlet is removed. drop it from object clause. So added it to numeric clause, we drop it now. Add a cell in product. Select the cell. From there, less. Now drop it from the object clause. Object clause. Drop. No, object clause. Open bracket, single quote. Item underscore objects. Okay. Comma access is selected. And all the things will get it. Okay, I've talked to you about the other process, right? Get dummies. We will also look at the get dummies. How we got the get dummies. This all of you have done, right? So object calls dummy is equal to pd dot get underscore dummies object calls object calls dummy dot now you can see here earlier fact content was done in one column 0 and 1. Item fact content was done in one column 0 and 1. Now it created two columns. Low one column, regular one column. Get dummies. You have solved the issue?
Yes.
Get dummies is another option of encoding. It creates new columns. Whereas in the old encode, it did it in a single column. Item fact content, it gives 0 and 1. Here it created new columns. See? Low fat, regular. Similarly, baking goods, breads, they did it in one single column. Here it created multiple columns. So the size of the data frame will increase. The columns will increase. Which one you use? For regression, this would be the better option. If you are running it in regression, get dummies is better option. When we are talking about regression, I'll tell you why get dummies is preferred than label encode. All right. Now we have completed the label encoding process. Now we are ready to combine our data back to normal. So combine df underscore clean is equal to pd dot concat square bracket num calls comma object calls encode. I will use encode comma axis is equal to 1. Column concatenation. Earlier we did row concatenation. Here we are doing column concatenation. Encode only I am using. I am not using dummies. To show you the difference, I have used the dummies. Here we are using encode only. So sigma train df is equal to combine df clean square bracket combine df clean dot item outlet sales not equal to test. Big not test df is equal to combined df clean square bracket combined df clean item outlet sales double equals to test. Then big mart test df is equal to big mart test df dot draw item underscore outlet underscore sales access is equal to 1. So first we have done the object calls encode, right? We have concatenated them into one single data frame. Object calls encode, I have concatenated them into one data frame. Then I separated the data frame as bigmart train df. I have added the df to it. Not equal to test is train data, equals to test is test data. Then I have dropped the variable which you have added in the beginning for concatenation from our test data. Okay, so first we are concatenating the data frame. So we have label encoded the data here. If you look at the variables here, we have done the label encoding here, encode. After label encoding, we have combined them into one data frame. We have combined them into one data frame, and then we have separated the training test using not equal to test as the thing, and the second one we have used it as equal to test. This is not equal to test is train data, equals to test is test data. Then we have dropped the variable which we have added in the beginning from the test data. Yeah. No, we didn't run the code, limited code itself. This is wrong actually. We have missed multiple commands. I'll show you one second. Hold on. Item of cells has no attribute item. Data frame does not include item of cells. Slowly down. See. It also brought it inside. But not also valid. And from there. Okay. Got it, all of you? Hmm. Hmm. Yeah, tell me your email ID. V R A M V A S D A S. V I K R A M D A S 223 @gmail.com. See, I am sending you notebooks, open them, see where you have made mistakes. All of you correct the mistakes. Whoever is stuck there, I am just sending the notebooks. Just download the notebook and check where you have made the mistake. And I'll also help you to clean the notebook.
So why did you stop this?
Huh?
Why did you stop this?
Concatenation, we have to see, here we have separated the data, right? We have split the data frame into numerical data and object data. We have to combine it back, right? Once you split it for pre-processing, you have to combine it back to the data frame. The data frame consists both numeric and object data. So we have to get it back to the same position, right? The initial data has both numeric and object. We split it into two for pre-processing. Now we have to bring them back to the same state. That's why we concatenated them this time column wise. Numeric calls followed by object calls. Then we separated the data frames into, we combined them earlier into combined. Not equal to test is your train data, equals to test is your test data. Then we have added the column called item outlet sales in test data for combining. We are dropping it off. Now, one last thing is Bigma train item sales df dot item sales is will show it as object because it is showing as Panda score service. Huh? Okay. Oh, sorry. Bigma train df dot item sales dot d types. Data type is showing as object because we had it mixed now earlier. Earlier it was mixed. Some of it is test and some of it is numbers. Now we have to bring it back to what? Float 64. What was the initial outlet sales? The initial outlet sales was float 64. Because we have mixed the type, both number and object, the overall data structure is gone now. Now, if you look at the shape of the data, it says it is O. O means object. So if you say D types, it will say O, object. Now we have to change it to what? We have to change it to numeric, float 64. Train df dot item outlet sales is equal to Bigma train df dot item outlet sales dot as type float 64. As type float 64. Now, if you do the D types, it changes to float 64. So you have to change the data type to float 64. Correct it or no? Download it from the base. Yeah, fine. Here onwards, okay, so the numbers command is control it. One. Copy this from there. The data in process. Click on that and go to the next line, next command. Copy and paste. So all the download notebook which I sent it, open it in your Jupyter and then type it. You guys have done it, rest of all you guys have done it without any error. You guys have done it? All? Now, once you have converted it into float, let us check our dependent variable. Create histogram, box plot, and density curve of item underscore outlet underscore sales and interpreting it first. Okay, so what do you see here? What is the inference? So here, Big Mart train DF dot item outlet sales dot plot kind is equal to hist. Kind is equal to hist for histogram. So what do you see here? What is your inference? Positive skewness and kurtosis. Both skewness is positive and kurtosis is positive, right? Right? Left side. If the peak is onto the left side, positive. If the peak is onto the right side, negative. Here it is onto the left side. If you want, you can print also. Print Big Mart train DF dot item outlet sales dot skewness. Print Big Mart train DF dot item outlet sales dot kurtosis. See, you get the values both positive, and you can also see the graph. You can see the values as well as the graph, positive skewness and positive kurtosis. If you want to know what is what, you can add a decorator. Q colon is equal to comma cut colon double quote comma. Q and cut. You want to know what number is what. So the histogram clearly shows us it is positive skewness and positive kurtosis. Left side, all the bars are onto the left side. And there is a single narrow bar, single narrow tall bar is there. Sorry, tall and narrow bar is there. That shows it is a positive skewness. If at all you get confused, please print the skew and cut and then analyze. Right? Now box plot. Box plot, same thing, kind is equal to box, what is equal to false. Big Mart train df dot item outlet sales dot plot kind is equal to box, kind is equal to box, comma, what is equal to false. We can see that clearly box is skewed towards the left and there are outliers on the right. The dotteds are your outliers, extreme values on the right side, and the box position is completely to the left, which indicates positive skewness. Outliers are extreme values that are outside the normal range. Similarly, Big Mart train df dot item outlet sales dot plot kind is equal to density. Tall and narrow peak, positive kurtosis, and the peak is onto the left side. So it is positive. Now, if I want to correct this, what should I do? Check the pre-processing notes. If the dependent variable is positively skewed, what should we do? If the dependent variable is positively skewed, what should we do? That is the second alternative. First one is what? Logarithmic transformation is the first one. 95% of the times, log will work. If log doesn't work, then we go to square root. That means instead of taking the actual values, we'll convert them into log values. Let us see if log will do some justice to the data. So based on the three plots, the density plot, the box plot, and the histogram, our dependent variable is highly positively skewed and also positively kurtosis. Now let us see by, and in the transformation I told you, np.log Big Mart train df dot item outlet sales dot plot kind is equal to box, comma, what is equal to false. So it didn't work. Now it converted from positive skewness to negative skewness. It converted from positive skewness to negative skewness. That means the strategy has failed. Now, what is the second strategy we have? np.sqrt, square root. Square root is moving slightly middle, but not much change. Square root is doing some sort of thing, but not much of a change. So in this case, transformation of dependent variable is not working. So we have to keep the data as it is. And another thing is, there will be some stores that have higher sales, some exceptionally good sales. Some stores will have bad sales. Will all stores perform same? No, right? Some of them will have exceptionally good sales. Some of them will have exceptionally bad sales. So we need to keep the outliers in the data. The outliers here will represent a data pattern. So what we have to do, we have to find a machine learning model that works with outliers. Like advanced models like decision tree, random forest, boosting machine, neural networks, they all work well with outliers. Basic algorithms like multiple linear regression, they won't work well with outliers. So that we have to go for such algorithms. So we have done basic pre-processing. We have understood the data today and various activities we have done. As we go through the course, we will be going through different types of pre-processing. The one basic one which you need to do on most of the data we have discussed today. Okay, so basically we are not able to correct the skewness. We are not able to correct the skewness here. So we'll keep this data as it is, and then we will build models. Okay, it's 12:45. Shall we end today and then we'll meet in the tomorrow's session. You have any doubts, you can ask me now.
Send me the notes of the previous class.
You want the previous classes, huh? First of all, let me add you to the Google Drive. 22. Okay, last session's video I didn't upload, huh? Oh, so sorry. Your email ID, please. Vikram. This one, right? So I'm added to the folder where all the videos will be there. Last session videos. I will upload the last session video also. 1 second. Documents, Zoom. Last session is what? PGA 22, 18th, right? Hey, what did you do in the last session?
So we have imported
Descriptive statistics.
analytics.
PDA 2, descriptive stats plus data visualization. 18th only, right? We have done it on 18th. This is on 17th. Yeah. File upload, users, documents. 18. So I have given the drive folder access. Both the two session videos are there, and you want the files, right? See, the PDF file will have the notes also. Okay. For opening the Jupyter notebook, you have to go to the Jupyter, or you upload it into your Google Colab and then open it. So I have uploaded both the session videos. Today's one also I'll upload. I am ending the session online